Hello everyone, I am Shiv Prakash, Research Scholar, Department of Electrical Engineering, IIT BHU. Let us start the session today with the design of the photovoltaic system. In this assignment number 7, we are telling about the MPPT algorithm. MPPT algorithm is required for the taking the maximum power from the solar system. Like if you have a solar PV solar panel, and how you get the maximum power from the PV, then you have required the MPPT algorithm or some upper controller like MPPT controller, and how to control the power. MPPT work basically to the matching the input uh, impedance to the output impedance. It means the matching the input impedance of the converter to the matching the output impedance of the solar panel. If you match this one, then you can get the maximum power from the PV. Like if you have a PV system, then you have required DC-DC converter. Then you will get the output. If you take a variable load like I not, this one is the V naught. This is the terminal voltage of the PV panel, so terminal current of the PV panel. Then in any DC-DC converter, the control input is only the duty cycle of the switches. What number of switches are used in the converter? Maximum converter use the only one switch, like a buck converter, boost converter, and buck boost converter. But sometimes as some of converter is there, they use the 2 or 3 switch also, like a 3-port converter, another like a 2 switch converter. And to you can only control the switches by giving the duty cycle to control the output, or for the maximum power point you can match the input impedance. It means to to match the impedance, to find impedance you are required the voltage and current. To sense the voltage, this is a series connection. To sense the current, to the series connection. To sense the voltage, you can sense the Vt from here. This is the It, this is the Vt. Then we have MPPT controller, the different type of controller. And controller gives the duty cycle or gives the value. Then that value passing through the passing through the PWM generator. After that you get the duty cycle. I have written directly here duty cycle D. Sorry, there are many type of controller, MPPT controller. like a reference cell method. These are two type of voltage to voltage sense and by the current sensing. Second is the voltage sampling. Third one is the power slope method. Next one is the hill climb. This is the method, that is the MPPT controller which one you used in your controller, MPPT controller, to get the maximum output of the PCB panel. The most usable method is the power slope method, which you can compare from the power to sense the voltage and current both, but you require both the current sensing, but here only voltage sensing required. Here is the current sensing requirement. Voltage sampling method is, these are also two types of current sampling. There is a sampling method only. This is voltage sampling and current sampling. Current sampling also, there are also requirement of either voltage or current, but in power slope method you are required both voltage and current. A hill climb method also required both power and voltage and current. Let's start the questions. Which is the more accurate scaling reference cell method? There are voltage scaling method and current scaling method. And which one is the more accurate scaling? I think you all remember about the circuit diagram of PV panel, PV cell. Voltage scaling in current scaling. I think. Wait. I give you an answer. This is cell voltage, terminal voltage and cell terminal current. This is the PV cell. Identity is the IP. I think you all remember this one. This one ID current. This one shunt resistor current RSH, RSC. This voltage is V minus of this one voltage minus of I into RSC. Oh, sorry, plus of this one. This voltage plus this voltage drop is that one. That's node voltage. I think all of you remember this one. Then after calculating the current, you got this one IP, the current, this one terminal current relation between all of things, I naught e to power of V plus I into RSC. This one the diode voltage, the diode current expression I naught is the saturation current of diode minus of this voltage drop. This I is equal to this current minus of this current and minus of this one current. This is the diode current, and ISH is the V voltage, terminal voltage divided by RSH. So V plus I into RSC divided by of RSS. This is the current expression of any PV cell. Where a shunt resistance is very larger than the series resistance. And find the short circuit in scaling of the voltage and current method. In voltage method, you scale the VOC in terms of Vm. It means Vm is equal to K times of VOC. In current scaling, we scale the short circuit current ISC in terms of for the IM maximum current rate. Point is the ISC into K, or K1 is the ISC into ISC. It means you have required of ISC and VOC. To find the ISC and VOC, you get the short circuit or open circuit. You know about the characteristic, IV characteristic of PV. This one is the VOC, this one is the ISC. In short circuit condition, I is equal to ISC, short circuit current, and voltage, terminal voltage will be 0. If you short this one voltage will be 0, current will be ISC, short circuit current of the PV panel. And put the equation on this one, that equation number first, take this one. Then I is equal to IP minus of I naught, voltage 0, it means e to power of I into R divided by NPT, I into R SE, not R, because of this one. This voltage same appears to the diode voltage, that's why V plus I into RSC. V is equal to 0, that's why I will take N into Vt minus of 1 minus of ISC in place of the current. I is the ISC, short circuit current, into RSC divided by of RSS. Because of the RSS is more than the RS is larger, very larger than, that's why it will be neglected. This is usually also very less in compared to the this one. This will be approximate of 0, that's why this will be also 0. Then I directly proportional to the IP, and IP is directly proportional to the solar power of insulation. Okay, same thing I apply for the open circuit voltage. This one will be short circuit current, I think. I, it means this will be short circuit current directly proportional to IP, solar power insulation. Open circuit apply for the in this one will the VOC, V is equal to VOC and I is equal to 0. Then this one I is 0 means this one is 0. IP minus of I naught, V is equal to VOC. This I is 0, VOC divided by NPT minus of 1. This will be VOC and this will RSS. If you apply this one, you will get the I is equal to 0, this will be IP minus of I naught e to power of VOC divided by of NVT minus of 1 minus of VOC divided by of RSS. This RSS also very larger than the VOC, that why you can neglect this one also. If you solve this one, then you will get the VOC is equal to NVT into ln of IP plus I naught divided by of I naught. And ISC is directly proportional to of IP. Now you can say the which one is the more accurate in terms of IP. IP is the insulation. IP directly proportional to the insulation power. Here the insulation power in algorithm, but in the short circuit current, in the current scaling, the IP directly proportional to the current scaling. That's why the current scaling is the more accurate than the VOC, voltage scaling method. Because of this one, the current short circuit current is directly proportional to the solar insulation. That's why a current scaling is the answer of this question. Okay. For the next question, for the voltage scaling reference cell method, find the value of Vt into 100 in volt within 2 decimal point. For the specification below and the given controller in the diagram. There is the controller is given here. This is the converter given where is apply for the MPPT. Note that please carefully see the asked value, which is asked. Find the value of Vt into 100, the terminal voltage into 100. Then assume the ideal circuit and DC-DC converter is operating under continuous conduction mode. This converter is continuous conduction mode and ideal operation. This problem is already solved. Okay, fine. Specification also given for the solar panel, solar system. Output voltage is given 15 volt. Open circuit voltage is given at 32 volt. Voltage scaling ratio is given 0.7. Proportional gain controller of this one is also given 10. Then converter is buck boost converter is given. A DC-DC converter is buck boost converter. Vm is given is a K for the scaling, voltage scaling method. Vm is equal to K1 into VOC. K1 is given 0.7, VOC is 32 volt. Then this one will be 22.4 volt. Output is given is 15 volt. This is a buck boost converter. The maximum voltage, this voltage is applied to the buck converter. It means this is the input of the buck converter, same as the 22.4 volt. Then you know about the output voltage. A buck converter is D V in divided by F 1 minus D. Then find the value of D. D is equal to V naught divided by F V naught plus V in. V naught is given 15 volt. B is 22.4 volt. After solving this one, we will get a 0.4 value, 0.401. We will get the D is equal to 0.4, approximately this one. From the controller, you can say duty cycle after this one controller duty cycle is from this one is Vm into K1 minus of this one Vt after multiplication of proportional gain is K is equal to D, and this one will be 0 and D will be maximum, and this one is the maximum, then D is equal to 0. So that's why D is equal to this one. Vm into K1 sorry, this one is Vm, not Vm, this one is VOC, VOC. After multiplication of K1, this is the Vm, maximum power voltage at the maximum point. Then comparison of Vm and Vt in that point. Okay, this was the VOC, not a Vm. VOC is 32 volt, and this one is the 0.7 minus of Vt. K is also given 10. This one 0.4, 24 2.4 minus of Vt divided by 10. Then what is the Vt? Vt is equal to 22.4 minus of 0.04 divided by 10 here 0.04, then Vt will get the 22.36 volt. And the question is asking about the Vt into 100, then multiplication of this one 22.36 into 100, this will be 2236 is the answer of this one question. Okay, next question is given from this specification of the question 2, same. Find the error as the given VOC minus Vt into 100. Error is given VOC into K1 minus of Vt into 100. Same thing, this error VOC into K1 is Vm minus Vt. Error of this one. We calculate this one is 22.4, Vt is 22.0 or 22.36, zero 4 into 100, this will be I think 4. Next question is given upon the same question. Find the duty cycle of T within 3 decimal. I think these are already calculated, this one 0.401. And next question is which of the following circuits will provide the output voltage waveform with respect to the applied gate drive voltage. Explain 3 problem. This one, let's give the same question. Question number second is and asking about the find the error. Error is given into VOC minus VT. It means a VM minus VT into multiplication of 100 is given. VM is K1 into VOC and VT already calculated at 22.36. Question number first. This one VT is 22.36 and VM also calculated here. K1 into VOC it will be 22.4 and 22.4 minus of 22.36. It will be 0.04 into a multiplication of 100 is given in the question. That's why it will be 4. And next question, the duty cycle also I have calculated. Question number 5. Which of the following circuit B, option B, which one? This one. Okay. Same question. Which of the following circuit will provide the output voltage waveform with respect to applied gate drives voltage waveform as shown in figure? This is the waveform is given. Same as the waveform of a gate, but at different voltages. This will be the different voltage level. This one voltage level. It is given that it means the same voltage will be in the same phase. When gate pulse is high, then same thing output voltage also high. It means of the question in that question. Then which one is the correct? Okay, comes to the option. Option A is given. This one VDD applied. This one resistance VG. When VG is high, this one. When VG is high, you apply this one. So base voltage is high. This is the NPN transistor. Base voltage is high. It means transistor is high. Then VDD is if base voltage is high to that one, it means that all transistor will be turned on. Yeah, all will goes to saturation mode. That's why this will be a output of this one is this will be turned on. Output of this one will be 0. Okay, don't confuse of this one. All transistors are working on the off, cut off and saturation mode only. It is the on and off. In any is here is usually for the switches purpose. It will be on or off. To check this one, think about only the base current, a base voltage. If the base voltage is 0, it will go to ground, a minimum to the VDD, then PNP transistor will be turned on. If the base voltage is given a supply, some voltages, then that time the higher voltage, then that time the NPN transistor will be turned on. Now either all of these will turn off. Same thing looks here. There is the voltage applied here. Some voltage VG is high. It means the base terminal is high of this transistor. That's why this will be on and this will be on. It means that this terminal is grounded 0. That's why voltage also 0. And when this will be 0, this will be suppose like a 0 1, but this will be 0. It means this will also 0. Then this transistor will be turned off. In off condition, this connection is not there. Then only this terminal is open circuit. Behave like open circuit. like this one, voltage asking between this one, it means VOC same as the VDD. This voltage appeared here because of the current will not flow, then V output voltage is same as the VDD. It means when switch is off, the pulse is 0, then voltage is there, and when the pulse is high, then output voltage will be 0. That's why this will be incorrect. It will be opposite of this one. Okay, comes to question number option B. Same thing, same pulse applied here. Suppose this will be high. It means this will be high. This will be turned on. This will be turned on. It means this will be ground. Like a switch on or off only. If this is on, this resistor is directly connected to the ground. That's why this will behave like a 0. This is a PNP transistor, not NPN. This one is a NPN transistor. In NPN transistor, base will be high. In PNP transistor, base will be low to on the transistor. It means this will voltage is low, base is low. This means transistor will be turned on. This one will be turned on. Then this current will be flow like that. Then all of voltage drop across the resistance. That's why the output voltage will be provide like that only. This is a high. This voltage will be also high because of same voltage appear on the this resistance. When pulse is high, then this transistor will be on. Same voltage appears here, then output will be same VDD. But when it will be 0, then this transistor will be 0. Then that voltage is appear only here only. Here is the open circuit. We have like open circuit. This voltage is here, and same voltage appears here. That's why this will be a turn off. And this will be a turn off. Then this ground is appear on the output voltage. That's why this will be when pulse is high, then output pulse also high, and if this pulse is low, then output pulse also low. That's why this will be a correct expression for this waveform. Okay, let's check the option number 3 also. Same thing. If this is a high, take like 1 high here. This is a NPN transistor. NPN is means this will base is high. It means this transistor will be high or on. This will be on. Then that resistor is connected to the ground. Then that base is 0. This will be a PNP transistor. And this will be ground base is 0. It means this transistor is on. Then this transistor is on. It means the higher voltage appears on the base of this one. Both are connected through the base. This will be high. It means this will be high. This is the NPN transistor. This high, it means the output voltage will be directly connected to the ground. The output will be 0. It means the pulse is high, the output will be 0 because of this one. If this one is be high, if this one is a high, it means same voltage appears here, some voltage appears here, then this will be high. The transistor will be high. This transistor will be low. It will behave like open circuit, but this one will be a short circuit. Then the output voltage directly converted to the ground will be 0. Suppose this will be 0, then this will be off. This will be off in open circuit. Then that voltage same appears on the base of the PNP transistor. And this will be high. It means all transistor will be turn off. Then turn off. Then this will be connected to 0. It means 0 appears on this base because of the resistance is directly connected to the 0. This will be 0. It means this transistor will be turned on. this will turn on, will be act like this one, this will be turned off because NPN transistor current flow like that. It means this will be 0, then V output will be high. Vg is equal to 1, then V output is equal to 0, and Vg is equal to 0, then V output will be 1, opposite of this one. But it will given as the same waveform. Same waveform follow only the second option. That's why this will also now incorrect. B option will be correct. Next question number 6 is given for the IV characteristics of a PV panel. Find the terminal voltage in volt at which the maximum power point happens. Given like I current minus 0.1 V square plus 24.3. It is also mentioned as greater than 0, greater than or equal to 0, voltage also greater than or equal to 0. It will not negative. Not terminal voltage is not a negative, current also not negative. All of you know about the power. Power is equal to V into I. Then dP by di, dV. To differentiate with respect to the voltage, the current will be expression of the voltage. That's why this will be first and second, and multiplication of the two variable. If you take a voltage first into second option, someone said 9 volt. Yes, this will be correct. First into second differentiation, it will be di by dV plus second into first into differentiation will be 1. For maximum power, dP by dV will be 0. That's why a V into dV, di by dV plus I is equal to 0. Then di by dV is equal to minus of I divided by a V. For the maximum power, this will be a for P max. Okay. I is given minus 0.1 V square plus 24.3. Differentiate this one with respect to the voltage. This is minus 0.2 V. This will be constant value, it will be 0. And this is the same as the for P max, it will be a minus I by V. Then this expression is G minus 0.2 V square is equal to minus of I. Minus minus will be cancel out. Then 0.2 V square I I is given minus 0.1 V square plus 24.3. And there this one is 0.3 V square. You will transfer this one to the left hand side. Then 24.3. Then V square will be divided by a 24.3 divided by a 3, it will be a 81. Then V is equal to plus or minus 9. But in the question is given this is only positive value. That's why V is 9 volt only. Plus 9, not a negative of 9 volt. Same thing apply this one, differentiate with respect to voltage, and equal to this one for P maximum power point, then find the value of voltage, putting the value of I, same thing in the given question. From the question number 6, find the maximum power point. It means what is the maximum power? Same thing, power is equal to V into I. Voltage is the given and current expression is given minus 0.1 V square plus 24.3. V is given, V I have already calculated 9 volt, 145.8 watts. Correct option, correct answer. Minus 0.1, V is 9, square of 9 is 81 plus 24.3, then we will get the I is equal to 16.3 ampere, then power V into I, 9 into 16.3, it will be 145.8 watt. Next question, from the question 6, for V is equal to 7 volts, select the one of the following options. dP by dV greater than 0, dP by dV less than 0, dP by dV equal to 0, none of the above. Option A, dP by dV is greater than 0. Yes, this one is the left of the MPPT point. That's why at the left of the MPPT point is dV by dV is be 0 because of the voltage and the power both are reduced. If the both are reduced, it means the minus will be cancelled out, positive value is there. That's why dP by dV is greater than 0. At the right hand side, maximum power point, at the maximum point, the right side will be voltage will be increased and power will be decreased. That's why there is the some inversible. That's why this is the negative value of dP by dV. If you want to check this one, then you can check also. P maximum already calculated 145.8. Take this one as a P1, 145.8 watt, and V1 also at maximum point is 9 volt, and V2 is given 7 volt. At V2 calculate I2, same 0.1 V square plus 24.3, I think put a value of 7 volt here. This will be V2, 7 square is 49 into 0.1, 4.9 plus of minus 4.9 plus of 24.3, it will be a 135.8. Then what is the power? V2 into I2, sorry, this one is 9.4, 19.4, then multiply of this one, it will be 135.8 watt. And dP by dV is the same as the dP2 minus P1 divided by f V2 minus Vp minus of V1, 138 0.5 minus of 145, so this one 35.8, 9 7 minus of 9, this will be a minus 10 divided by a minus 2, to will be a 5 positive value, till it means greater than 0. From question number 6, from the question V is equal to 10 volts, select one of the following option. Same thing in greater than this one, you can apply same thing also. Now you will get the dp by dp is less than 0, because of the voltage will be voltage will increase and power will be decreased, and power P2 minus of P1 will be in a negative value, and V2 minus of V1 will be positive value. That's why overall will be negative value, less than 0. Okay. I think someone is asked about the solve problem related to the how to find load resistance for the maximum power point. If you used the converter, yeah, DC-DC converter, then there are not requirement of the load resistance. Or if you want to fix the duty cycle, if you want to fix the duty cycle, and that time you have required of the load resistance. The same formula you can use the RT in the function of duty cycle and or not in all the DC-DC converter, like buck converter, boost converter, and buck boost converter. Or not in the RT is the function of the this one, and there from this one you can calculate the value of load resistance. From the question 6, for the power slope method to control as shown in the lectures, select the values for which the output of a comparator after absolute value calculation is positive. Yeah, anyone given the option is 12 volt is the correct option. Then power slope method means mainly in IV characteristic. The maximum. There are 2 to 3 points. This one is the lower than this one, maximum power. In right side or left side. If you take this one voltages, if you have a question, then please share the question. I can understand what you are asking. If or not is not given, but power is given, by using power, how to calculate the load resistance? Which one power is input power or output power? Then if you input power is given, then you can also calculate the output power equal to the input power. In ideal cases or losses there, then should uh, add the losses also. If input power is given, then you can calculate the output power to by subtract the losses. If losses is not there, then same as the power of input power output power, and then you can calculate the or not by v square of or not. Peak power rating of the power rating is given of the PV panel. I think VM is there. Oh, sorry, PM is there. Then same PN apply in the DC-DC converter the input side, na. That takes same power for the output also. If a loss is not there, if loss is not given, then same power appears on the output also. This is two slopes when the left side and right side at the point of maximum power point. Now power slope method switches to calculate the resistance voltages and current, then applied the power. This is the voltage difference of power at a different power rating. Sorry. This point and this point, if you regulate this one at a point is the upper side or lower side, that's an you will get the voltages of 0 to 1 in form of 0 to 1 or in form of some voltages. Same thing power slope method, second VT and IT applied and multiplication of this one, then we will get the power. Then dp by dv, to calculate dp by dv, to take a power and voltage also. If passing through this one is switch is on off, then that's why you sense the voltages like that in pulses. It will not be 0 because of you sense here. If you sense here in some of voltages is there. This is the higher voltages, it means this value, and this is lower voltage is this one value. Between this one you can get same thing passing through the DC block voltage to subtract DC voltage. If you subtract this one DC, it means average of this one is the DC. You subtract the DC voltage, then we will get 0. We will get this one like that, minimum voltage to maximum voltage. Both are passing through the 0 voltage detectors. a zero crossing detector, like comparator type. If you this one is lower than this one voltage, then this will be a negative VCC. If this one is greater than 0, output is the plus VCC, like that. Add the both. Output of this one is the plus VCC and minus of VCC, like that. So passing through absolute value, it means the all of the negative value going through the upper bound. Same thing, there is the dp by dv is greater than 0. It means same voltage and power in the same phase, and they are add up of voltages and power. But in the right side, this is the left side, this will be a right side, then the dp by dv is less than 0. It means the voltage and power is in opposite, and that's why if you add this one positive, one is positive and sometimes negative, in the positive level with, I mean, left side this will be add up, and at right side some of the take right, left and right, this is at the left, this will be add up, and right side this will be subtracted. It means 0 value, it's given the 0 value if you add this one both power and voltage. Who had power and voltage both, at that point, if pointer is left of the maximum power point, then you will get the voltages, that's what VCC minus VCC. But at the right up side, pointer is right of the maximum power point, that's this is are out of phase, that's why it will be a given the cancel out of both, it means a 0 value is given in right up side. It's passing through the absolute value, it will be a positive. So left, this one right point. This means you have a pulse like on and off. Then this value passing through a comparator, a threshold voltage is there. It means same voltages passing through this one. If you set a VTS some point, if VTS is greater than this one negative voltage, then output of the comparator will be 0, because of VTS is 0. So comparator is used to given a minus positive, the opposite of this one, because of the duty cycle. If you positive, then this will be add of this one, because of this all of thing is for the buck boost converter. D at duty cycle 0 and duty cycle at 1, 0 to 1. If you write it this one, then you have required a pointer as here, then required of the duty cycle will be reduced, sorry, increased. So it looks to both this one and this one figure, right and left. Comparator is used to shift this one because of the buck boost converter. Suppose you have one left hand side, you have you are there in left hand side of MPPT, it means you should require to go to upper of this one. It means increase of the voltage and increase of the power. To increase this one, then duty cycle should be increase from here to here. This one increase this one, the power will be increases. This will be a load line. Load line goes from here to here. That's why this is should be required of the positive value to increase the duty cycle. Okay, sorry. Looks here. If your pointer is there here, it means this is the load line at this pointer. Then you are required of the load line is going to down. The requirement of load line going to down. It means the duty cycle should be reduced and left hand side. But your absolute value is given the higher value at left hand side. It means this higher value it will increase the duty cycle. That's why requirement of a comparator to lower this one and increase in right hand side, because of if pointer is there, load line is like that. To get the maximum power, you should requirement of the increase the load line or increase the duty cycle, but your absolute value given is the zero value. It will not increase the duty cycle. To increase duty cycle, that's why comparator is used to increase the value here to oppose the opposite to this one, to inverse of this one. At left hand side is 0, right hand side high, that's why this signal is increase the duty cycle. After that this one will be gain, and again after the filter is given to the PWM, main of this one only. Question is asking about this one, what is the voltage in this. So the value of it is the output comparator absolute value calculation is positive and right hand side of the pointer. In the question you have already calculated the maximum power point, like that. This will be 9 volt. If you want to positive value, then it should be a right hand side. This will be a right hand side, this will be a left hand side, and the right hand side, that's why the right hand side only one voltage is 12 volt. Left hand side this will be a all of thing, but left hand side we should be comparator requirement of negative value. Yes, if you calculate the positive value, then you should take a right hand side of voltage like a 12 volt here. As someone is asked, given how the duty cycle ratio of the buck boost converter should be changed in such a direction as if dp by dt plus iot is less than 0. And this one is the point value only, not initial considered here. Only changes what happened like a dp by dt voltages. If we take initial voltage also resistance, if we can consider the internal resistance, initial resistance, that will be not less than zero. It will be some is can be increased. That's why it will be an instant value only. After reaching maximum power. Okay, all of you, this will be the requirement of the comparator taking, and for find the positive value, we should take a right hand side of the pointer. That's why right hand side only one value is given like a 12 volt. Because the maximum power point di by dt is equal to, the something I asked about RT is equal to function of duty ratio and or not. What we put for if it was frequency or what? No, no, no. This is a function of duty cycle and load resistance. Not F is the only. It is the function of this one. Like RT is equal to of something 1 by d square into r naught, and somewhere it will be 1 minus d square divided by f d square into r naught. R is equal to d square by r naught, like that. Then this will be calls like a function of r and d, r naught into duty cycle and duty cycle. Don't be confused like the frequency. So what about the terminal resistance? Is resistance constant or change? Terminal resistance of PV panel depending on the IV characteristic. Only IV value. If you change the duty cycle, then voltage and current will be changed. That's why you change the duty cycle, the IV will value also change to match the R naught value or total RT value. Looks here like a PV panel and a DC-DC converter here. You have R naught value. Don't take a variable. Take as a constant R naught. Suppose you connect a load, then load is a constant. You can't change the load. If you take a variable or take a effect of transient effect, you want to show that is a different thing. But if you want to draw a motor or want to draw a load something light load like that, then the R naught will be constant. There is the voltage and current, Vt and It of this one. We have a resistance of input resistance like that, Rin of any DC-DC converter. It will be calculated for the buck converter, boost converter, buck boost converter and stuff. Like if we want to buck boost converter, P input is equal to P output. If we want to buck boost, P input is V in square of R in is equal to V output square of R output. V output you know about D by 1 minus D square of V in square divided by R naught. V in square cancel out, then R in is equal to 1 minus D divided by D. This will be a square of R naught. The R in, you should merge the R in to the this one. Vt divided by f it is RT. You should merge the RT is equal to R in for a maximum power point to take the maximum power from the in PV. But you can't change the load. Or load resistance is fixed. Then you only change the duty cycle, duty of this one. To change this one, the R in change, R in compared to the RT. If this is the match at any point, then you will get the maximum power from the solar. This is the phenomena of to take the maximum power from the solar system. But sometimes if we change the duty cycle, the current or voltage also change. And that time the Vt and the IT also change. Vt IC already changed. It is not the fix for the solar system because of the insulation. Current and voltage are changed at every time, every point. You can't be fix this one, and that's why this is a requirement of an algorithm to check where is the maximum point, and or how to merge this one RT to RN. If this one is the match, then maximum power will be transferred by the theorem of maximum power point, maximum power transfer theorem for the buck boost converter. This one. If you want to calculate this one, the Vin, you should know about the maximum power. From maximum power, you know about the Vm by Im from the solar panel. You can calculate the same as the Rin, then you calculate the R naught. This is the rough method only. Because the V and Vm and Im will be changed at every point, every time. That's why it can't be fixed. That's why we requirement of the algorithm. In modern day, we have used a microcontroller like FPGA or some Arduino also, you know, my STM microcontroller, Arduino, FPGA, DSP board, many type of microcontrollers there. To algorithm to take a coding of this one, to at every point it will be changed like that. The duty cycle also change at every point. We will get the maximum point to match the RT to RIN. The duty cycle will be continuously changed. If you if you change the load also, if you want to change or not, at that time duty cycle also change to match the input resistance. Then all of phenomena is doing in the microcontroller. If you take a microcontroller, the microcontroller sense the input voltage, output voltage. After that, calculate the maximum power. Calculate the power only, not a maximum power. Calculate the power. Then to take the power and voltage, dV by dt, dV by dP. To take this one, if this one will be greater than 0, it means our point is left hand side. Then simply decrease the duty cycle continuously. Where this will decrease the duty cycle till dP by dV is less than 0. If this one is less than 0, then that time dP by dP less than 0, then duty cycle should increase. Simple phenomena. To take the current, sense the current and voltage, calculate the power by V into I, then change this one dP by dV is greater than 0, then duty cycle reduce, less than 0, then duty cycle increase. This is a coding only in microcontroller. They are not fixed anything. RT is not fixed, or not. Sometime you can change load. That's all of working is the duty cycle only, to change the duty cycle. Okay, this one I think all of you know about this one. At the maximum power point, what is the di by dv? Same thing, if you calculate this one, v into I, dp by dv, v into di by dv plus I into v at differential of v is equal to 1. For p maximum, this will be 0, and di by dv is equal to minus of I by v. The option. A reference cell voltage scaling method is used to track a maximum power point for a solar panel. The open circuit voltage is 43.6 volt. Then the voltage as maximum power point is approximately. They are not all of clearly given, but approximately if you ask about this one, approximately is the Vm is equal to 70% of VOC. And if you talk about the ISC, then Im is 90% of ISC. Take this one approximate value. That's why 20% of this one 43.6. It will be I think 30.5 volt. Maximum voltage voltage at maximum power point, it not equal to the open circuit voltage. Never it will equal to open circuit voltage. Open circuit voltage always higher than this one. The maximum voltage as maximum power point is lower than the open circuit voltage. It will 70 to 80% only. But in short circuit condition, is the maximum current in respect to short circuit current will be 90%, 9 to 95%. The maximum duty cycle ratio of the following gate driver. Anyone can guess and how? There is a transformer. Transformer does not work on the DC system or DC voltage, but we have applied a DC voltage only there, DC voltage. Then to work this one on DC system, the DC voltage, then we should balance the flux of the transformer. Flux should be balanced at every point. It will be charge and discharge flux will be same. If the charging is greater than the discharging, then the transformer goes to saturation, and the discharging is more than the charging flux, then transformer is goes to zero magnetization. Always reduce the flux and it goes to zero. That's why flux should be maintained at a point. It means charging flux and discharging flux should be same. That's why is given 0.25, 0.5, 0.75. The maximum is the 0.5 because of the, if you charge this one as the maximum point at 0.5 duty cycle, charging flux is the voltage VCC into time. The charging, if you want charging VCC in DT, duty cycle, plus if we take a magnetic voltage Vm 1 minus dt time, it should be a 0. Average of the charge of this one will be 0. This will also known as the Volt second valence equation. If there is a switch is on, here, this will be on, core is magnetized by a VCC. This will be the reverse bias because of the VCC. Magnetized, same point is there, then the power is transfer here. But when switch is off, then this will be a dot polarity, plus is changed here. This will be plus, this will be minus. Then remaining flux, the remaining energy of the inductor will be discharged through the resistance and diode like that. This will be the off time. This will be on time, this will be off time. Then both are times maximum. If you want to take the maximum is the 0.5, half of this one. If you increase the maximum time of 0.5, charging time is more than the discharging time, that time is the, it will be goes to saturation. That's why the maximum duty cycle will be 0.5 only. You can operate below the 0.5, it is no problem, but you can't exceed the 0.5 duty cycle. The transistor Q1 in the question 3 is used to, where is Q1? This one is a Q1. Like the working of this one. When pulse is high, Vg high, this will be NPN transistor. It means the base is high, that will be on. This will be on, it means energize the coil. Same time, this will be positive, this will be positive, dot is polarity, will be positive connected to the VCC, that's why this will be positive. This will be also positive, no transformer. So forward bias, this is also forward bias. Then same voltage appears here. This is the PNP transistor. Please, this one check. The arrow is there, that's why PNP transistor. Then voltage, base voltage is high, it means this will be a off. The same voltage appears on the VGS, this will be a VGS of MOSFET. MOSFET will be turn on. Q1 is not working, it means not in the picture, in on time. Okay, and this one is on, this is a high, this will also high. Q2 will be turned on, it will be a short circuit, energize, this will be positive terminal direct connect to the gate. This will be a gate terminal, this will be a drain, this is your source. This one is only same, that's why it's higher is the base of a PNP transistor, that's why this will be a turn off. This will be turn off, this means same voltage appears on VGS, and it means in on time Q1 will be not working. Okay, hence this will be 0, this will also 0. At that time this will be reverse bias. This will be polarity will be reverse, this positive negative, this will be energized between this one. There will be a same thing, positive negative, and this will be 0 because of this one. This will be a voltage, there is some voltages till that this will be a not demagnetized, that's why some voltage is there, but this will be positive, this will negative, reverse bias. This will be a ground terminal connected to this one ground, this will not bias, reverse bias will not connected. This will be 0, it means PNP will be turn on. Then the charge carrier is discharged through the Q1. VGS, a capacitor of get to source, parasitic capacitance is discharged through the Q1 at off time. In on time Q1 is not used, in off time there is the use of this one because of the discharging of the capacitor through the resistance R1 and Q1. There is the speed up of the process. No, on process. Now this is the off process. Yes, this will now increase the process because of the discharge the capacitor quickly. Both time not whatever overcurrent. No. When BJT is used as a switch in buck converter, It operates in cutoff region during turn off and the saturation region during turn on. If a BJT used as a switch, it will be operating in only two modes: saturation mode or saturation region and cutoff region. In cutoff region, so it act as like a switch off, and in saturation region, it like work like on. That's why it's given a cutoff region during turn off. Yes, okay. In saturation region during turn on, same thing. In saturation region, it will be work like a active switch, like a one, and off time will be 0, like that. Linear region during the turn off saturation, no. Cutoff region during turn off, linear region, no. Only this one will be correct. BJT behave like a switch, only two modes: cutoff region and saturation region. Saturation region, if you check, this will be a turn on, like we have like a switch. The boost converter, buck converter, anywhere. Don't be confused in converter. It be asking about the only switch, about the BJT. Use as a switch in buck converter, the boost converter. If you want to operate in switches like a switches, and that time in cutoff region, it will be work like a turn off of switch, and saturation region, it will work like a turn on of switch, like a MOSFET. But the rating of the BJT is very less. That's why it does not used. And some other problem losses also. The IV characteristics at the terminal of the source is given below. Then is asking about the point A. What is the dP by dV greater than 0, less than 0, equal to 0, or di by dP greater than 0? Okay. Anyone guess what this one? All of you know about the voltage or power is V into I. If you got this one, V into I, then you can answer the any questions related to this one. Okay. First one, find the current expression. What is the current? I. This is the current slope of this one. This is the IV characteristic. It means this will be the current characteristic. If you take like this one, voltage is this one, the current is this one, like a x-axis and a y-axis. I think all of you know about the line equation in coordinate system. Y minus of y1 is equal to y2 minus of y1 divided by of x2 minus of x1 into x minus x1. Here y is denoted to I because of this is the y axis, and x denoted to the v because of the x axis. What is the coordinate of this one? This will be a x1, y1, and this will be a x coordinate is 0, y coordinate is is. This will be the x2, y2, then x2 is VOC, y2 will be which 0, y2 is 0 because of this is 0, this is y, this is 0. Then use this equation and find the expression of current. Y, it means I minus y1, y1 is ISC is equal to y2, y2 is 0 minus y1 is ISC divided by x2 is VOC minus x1 is 0, here is x1 is 0, x1 y1, x2 y2, this x2 y2, this is x1 y1, 0, x minus of x1 0. Now what is the I? If you transfer to the right hand side, it will be ISC minus of x is the V minus of ISC into V by VOC. This is the current expression. I is equal to ISC minus of ISC into V divided by a VOC. In the power V into I, V is V, I is ISC minus of ISC into V divided by a VOC. This is ISC into V minus of ISC divided by VOC into V square. ISC is a constant value because of the ISC is mentioned on the data sheet. VOC also mentioned. The VOC and ISC is a constant value. Only voltage will be variable. Then difference this one dP by dV. Then voltage will be 1. It will be ISC minus of ISC divided by a VOC into 2V. Differentiation of V with respect to 2V is 2V. Then for P maximum, dP by dV is equal to 0, then take as 0. Then ISC minus of 2 into V into ISC divided by VOC is equal to 0. Then ISC take a common, it will be 0, then 1 minus of 2V into 2V divided by a VOC is equal to 0. That's why V is equal to 0.5 of VOC. And this is also mentioned in the question, 0 point of VOC. This is VM. I think. At point A, V is less than the VOC, V is less than the V, VM. At point A, here this point is less than the 0.5 into VOC. Okay, let something, let 0.4 VOC. We can take this one 0.5 VOC, V is less than the 0.5 VOC. I will take like a 0.4 VOC, less than 0.5 VOC. Okay, then dP by dV is equal to ISC into 1 minus 2V divided by VOC. Here from the equation, if you take ISC common, you get 1 minus 2V divided by VOC. Take ISC is equal to 1 minus 2V, V is equal to at point A, ISC 1 minus 2V 0.4 VOC divided by a VOC cancel out, dP by dV is equal to 0.2 ISC. ISC is positive value, yeah, it will not a negative anywhere, positive value, that's why the overall will be positive. Then dP by dV is greater than 0. Same thing at point B. B is more than 0.5 VOC. Okay. Take V is equal to 0.6 VOC. More than 0.5, it means 0.6 VOC. Then check dp by dv. Same applied here. ISC 1 minus 2 into 0.6 VOC divided by VOC. VOC will be cancelled out. This will be a minus of 0.2 ISC. This will be a negative value. Then dp by dv is be less than 0. This will be a 1.2 na. 2 into 0.6 1.2. 1 minus 1.2 will be minus of minus 0.2. ISC will be negative value. Then dp by dv will be negative or less than 0. Question number 16 is given at point A, dp by dv is greater than 0. You also read in the previous here, the left hand side will be dp by dv greater than 0, right side dp by dv less than 0, same thing. But there is a current expression, not a power expression. That's why we come confused like that. If this is the power curve, then you can say like that directly that this is the current curve.
Sir, excuse me, sir.
Yes.
Sir, in IV PV cell characteristic. So
Where?
what about if operating point is lying on the left or right? So what will be the maximum power point, sir?
This is the maximum power point in the for the IC. This is not a power curve is there. That's why take only the ISC, a voltage and current, and differentiate to with respect to voltage. After that, we can say like where is the maximum point.
No, sir, I want to know about what is the relation between voltage and power, sir.
There, na this is question.
Which equation, sir? Yeah, this one.
This one
IS.
ISC into V minus ISC into V square. ISC will be constant. VSC
Ah,
VOC also constant.
okay, sir.
Then power is with V in terms of V minus V square.
Okay. So
ISC
in
into
order
V.
to in order to have maximum power, we need to equate it to zero.
Yes, sir. This one. That's why you calculate this one.
Hmm.
Differentiate with respect to voltage here, and this will equal to 0 here. Then find the V voltage
Okay.
in terms of VOC. Same thing for point B is less than 0. I think next question is for the point B less than 0. This is the current characteristic is the given. That's why we should calculate all of them. Suppose that a boost converter is connected as an interface between PV panel and the constant voltage DC bus for MPPT, and the operating point is at a peak power point. Now, if the insulation reduces, then duty cycle increase, decrease, or same. Same thing is asking about this one DC buck converter. This will the voltage bus, DC bus. This will be a constant DC bus. V out will be constant. This is the boost converter. VT and IT. You know about the boost converter output voltage. Output voltage is Vt, input voltage divided by F 1 minus T. If insulation is decreased, then Vt terminal voltage of solar panel also decreased. Then to maintain the constant output voltage, output voltage will be constant. In terms of duty cycle, this will be reduced because of the insulation. Then you should increase the duty cycle to maintain the output voltage. If you in 1 minus D, if we increase this one, then overall 1 minus D will be reduced. Then both are reduced, the way output will be constant. That's why to maintain the output voltage, you should increase the duty cycle in boost converter. Yeah, this one duty resistive converter of the we increase. Load not in your hand. If you connect the load, then you should decrease the duty cycle. Decrease and increase the duty cycle so that could maintain the output voltage. Reference cell method based on current scaling is more accurate than the reference cell method based on the voltage scaling because the sense current is directly proportional to insulation level. I think this was the first question I will already solving this question because of the current ISC is directly proportional to the IP. IP as opposed to the insulation levels, and IM in a is equal to K into ISC scaling in current scaling method. From the IV characteristic of PV cell, which of the following statement is true for the operating point lying to the right of the maximum power point? So VT is on maximum power. So left, this one a right. Ripple signal of P and V. Ripple signal of P and V, it means delta P and delta V. You can say like delta P and delta V are in phase. It means d by dt is simply asking about the dv by dp by dv. On the left hand side, it will be a greater than 0 because of the PV also reduced and voltage also reduced. Both are reduced in left side. Then you can say power is directly proportional to V. If voltage reduced, power also reduced. If voltage increased, the power also increased. Left. But in right side, here you take this one, voltage also reduced and power also reduced here. Both are reduced in left hand side. And right hand side, voltage increase. This is the voltage line, but power will be reduced. Yes, mean delta P is negative, delta V is positive. These are opposite. Ripple of this one will be opposite. You can say this will be out of phase. In right hand side, it will be opposite, out of phase. If out of phase, it means you can say this one P directly inversely proportional to the voltage. If voltage increased, power will be decreased. But if voltage is decreased here, if voltage decrease, then power will be increased. If voltage decrease, then power will be increased. This will be inversely proportional. It will talk about the right of the maximum power point. This one maximum power point. The right is with the ripple voltage P and V are in out of phase.
Left, sir.
No, this one
Left it will be power is also decreased.
voltage also decrease. It means both are in
That's also
phase. Both are in phase. Here the
are
left.
in phase.
Yes. Here the given the ripple voltages P and V out of phase. P is directly proportional to V. No. Signal P and V are out of phase and P inversely proportional to V. This will be correct. For the right hand side. At the right of the PT point, the voltage power will be inversely proportional to the voltage. Voltage increase, then power will be decrease. But left hand side both are in phase. Okay, I think this one is the last question. Okay, everyone, I am stopping here.